Ready to go when you folks are. There we go. Thank you so much. This is such an honor. In the brief 10 minutes I have, I wanted to perhaps use pictures to replace 1,000 words. This award is named after Ted Codd, and we all know, of course, the lessons that Ted Codd has learned. They're taught in all our textbooks. Formalize your specifications and then automate your implementations and keep them separate, right? And that's sort of the big lesson of data independence and declarative languages. And in some ways, the work that I've done and my group has done over many years has been to take a broader perspective on Codd's lesson. It's really very, I feel that Ted Codd's a fitting avatar for our community and for the work that my group has done. And from my perspective, declarative specification is not just a small thing. It's actually the future of really all computing. When you think about it, the idea of separating specification from implementation is not just for databases, right? Codd's theorem and Codd's ideas are sort of been trapped in the database community, but really they have a much broader spectrum. As we all know, data is everywhere. All computation is essentially data-centric, right? And the lessons of this community really extend to all of computer science. And I encourage all my students, and I'd like to encourage our community to think in those terms. We did a bunch of work, for example, in my group over the years in applying the lessons of declarativity to the networking space, right? So Codd's lessons absolutely apply in this space. And if you want to learn a bit more about that, you can follow this QR code and read the CACM article from 2009 where we surveyed some of the early work here. And this is seen application in things like software-defined networks and IoT and sensor nets. These database lessons have actually taken foot in these communities where they have declarative languages for specification of things like packet processing and routing. So I think our community really did have a big impact there. Data science and machine learning, again, the QR code on our friend C3PO here, you can follow. Goes to the MadLib project, which we did back in, I think it was 2009 maybe. And this is work for doing declarativity for things like what is now called data science and machine learning algorithms. And you saw even in the dissertation talk today that MadLib is still an active project under the Apache Foundation, people still doing research in that context. And if you need to do machine learning inside Postgres, MadLib is your solution, so I encourage you to have a look at that. But for many years now, the database community has been contributing to the idea of doing machine learning and data science in this fashion. And I think even we had a keynote this week on that topic as well. A space that I've spent a bunch of time and continue to work very actively on, though, is declarative approaches to programming the cloud. The cloud is the biggest computer that humankind has ever assembled. We're still programming it with sequential languages like Java, which is absolutely an abomination and incredibly expensive and expensive to maintain. But when you think about it, relational databases were invented to hide how data is laid out and how queries are executed, right? That's sort of Codd's theorem. The cloud was invented to hide how computing resources are laid out and how computations are executed, right? If you want to program an elastic infrastructure that grows and shrinks over time and uses different kinds of hardware with workloads, you want to specify that at a high level and then have it evolve itself over time with workloads. That's precisely the kind of thing that Codd was thinking about and that our community is so very good at. And so I really firmly believe that there's huge opportunity for the database community to take our lessons, dig deep, and extend them to the cloud and to declarative programming for the cloud. And I have a wonderful team at UC Berkeley and Sutter Hill Ventures exploring this in a project called Hydro, which is just getting off the ground now. Our software is beginning to mature. Papers are beginning to pop out, and I'm very excited about where this is going. If you meet some of the Hydro team here at SIGMOD, please say hi. Great folks. It's hard, especially with my slides, not to talk about generative AI in 2023, and I want to talk about it in two terms. I think it's easy to get concerned that this stuff is going to displace all of us and Ted Codd, right? Maybe it's just the AI that's going to do all this mapping from a high-level specification to implementation. So I want to talk about this in two frames. First, let's start with programming, okay? So in the programming environment, I believe that declarative specification is actually going to be the narrow waist between the sort of green goo of AI and the hardened infrastructure that our community is so famous for having built. All right, so when you think about these AI systems, they generate stuff that's kind of dangerous. You can't really trust it. It's exciting. If you've programmed with Copilot in a language like Rust or Java that's well typed, you know that it'll generate stuff, and the compiler will say, no, that's wrong. You have to fix it, right? So you're held by the specification language of the type system of your programming language, on a sort of statement by statement basis in a procedural language. By contrast, if you program with Copilot with something like Python, it happily generates you programs, and they will run, and you have no idea what they're doing, right? It's really, Python's a language for people, not for AI, actually. But what we see is when you don't have that sort of specification harness, every line of your program might be doing something crazy. So take that metaphor of a typed language and raise it up to a high-level declarative language, and now you've got something really powerful. You can ask the AI to generate specifications of a program from a vague description. And those specifications can really be at the level of like what your program should be, what its outputs should be, not how it's implemented, right? COD. And then underneath that, we can deliver the technology to harden those things into code that is efficient, reliable, and manageable over time. And I believe there's huge opportunity for the database community to be that narrow waist between the kind of mushy goo of maybe this program works, maybe it doesn't, and the efficient, scalable, elastic implementations that you can build a foundation with. So I think we have an enormous opportunity, this community, in the era of generative AI for programming. Now let's think about human-computer interaction or human-AI interaction. And this is a space where also our community, and particularly people I've collaborated with, have worked on. We did it in the realm of data wrangling. And so we have a paper back in CIDR 2015. Again, you can get the QR code there and follow it, where we talk about predictive interaction and the idea that when a human and an AI agent are interacting, you need to have a feedback loop. And in that feedback loop, the human can very vaguely guide the AI system to its goals. In our realm, that was pointing at data visualizations. This bar in this bar chart looks crazy, it can't be right. This cell in this spreadsheet looks weird. And then the AI could suggest remedies that are, say, data cleaning steps in a data cleaning program. And then it would visualize, much like web search visualizes, a ranked list of suggestions, each of which could be mapped back again into the visual domain as data visualizations of the outcome of the transformation. So it's all visual all the time. The user is staying in a no-code environment. But they get this ranked ordering where they get to decide what the AI interaction should do. And then they do a feedback loop of this over and over, step by step. This guide-decide loop, I believe, is the right frame to think about interactions between humans and AI. And it really does come out of thinking about database problems, okay? So I think we have a lot to contribute also in the user experience of these things, and folks who come to workshops like Hilda and so on have been talking about these things over the last decade. So it is a time of great innovation in computer science, and it's easy to think that things are moving too fast. But there are some things that I think are continuous throughout the ages of computing, and I think that our community's foundation and declarativity and sort of Ted Codd's ideas are part of that continuity. And for folks who are young starting in the field, I would say the future is very bright, and you folks are more likely to be able to adapt to what's coming than some of the classical painters in the field. This is an award that I could never have won without the help of so many people, so I will beg your patience if I take some time to thank some folks. First and foremost, the family I grew up in. My mom was a database professional going back to the days of COBOL, and my dad was a professor, so I'm really not a very creative person. I just kind of took a little of this and a little of that. They've inspired me so much. And then my two big sisters who paved the way for me in so many things, including how to become an academic. I'm very grateful to my roots. I'm a very fortunate person. My research advisors over the years, Meishin Shu in my undergrad at Harvard, Hamid Pirahesh, my first mentor at IBM when I did my pre-doc there at IBM Almaden, very formative time for me. Mike Stonebreaker, my master's advisor, and of course, Jeff Naughton, my PhD advisor. All were people who brought me in and made me feel confident and held and taught me how to do what I do. My mentors at Berkeley, these lovely folks who made me feel like I belonged even though I knew I didn't, and allowed me to grow into my job and showed me the way and gave me opportunity. My colleagues in the Berkeley database group, I've had sort of three eras at Berkeley. There was the Joe and Mike Stonebreaker era, that was followed by the Joe and Mike Franklin era, and now I have such a wonderful team of colleagues that I get to play with. I'm just incredibly grateful to have them around, and all the ferment and excitement that's going on at Berkeley today is such a pleasure for me, and I learned so much from my colleagues. I've learned much from my teachers and even more from my friends, but from my students, I have learned more than from all of them. These are my PhD students. It's just a remarkable cohort of people. These awards for academics are really awards for your students. You can't, the work that we did at Berkeley in my group is their work. And so for those of you who are here, congratulations to you, and thank you for all your inspiration and all your sweat, and congratulations on all your successes. And for those of you who are still in my group, there's going to be a lot of fun to come, and you have a lot of big brothers and sisters to show you the way. And my postdocs as well, very much in the same vein, wonderful people that I learned so much from and was really grateful to have time to spend with them. One of the biggest adventures in my career was our startup, Trifacta, which ran for a full decade. I got to learn how to become an entrepreneur with Jeff and Sean. They were kind enough to let me try to be a CEO for a couple of years, which was very exciting. What a learning experience. We raised quite a bit of money and made very many mistakes, and saw great fortune nonetheless. And then we brought on Adam Wilson, who became a close friend to run the company like a real company. This was one of the most meaningful professional experiences in my life, and I'm incredibly grateful to not only these three folks, but to the whole team across the world at Trifacta, which is now a part of Alteryx. And then the home team, these ladies, center of my life. I'm just so grateful and proud of them, and happy to have a couple of them here today. Okay, this talk wouldn't have been possible without a few things. I can tell you all about the pros and cons of the state of the art with this stuff, having spent the last 4 or 5 days deeply embedded. And then if you prompt Midjourney to plot ACM SIGMOD, you get stuff like this. So thank you to the whole community, the awards committee, all of you. You look a bit like something on this slide. I hope you find yourself somewhere in here in some inspirational way. My gratitudes.
We do have a little bit of extra time, so if anybody has any questions that they would like to ask Joe, now is the time.
If they involve email I haven't responded to, I will not take them.
I'll go ahead and get started then. So, Joe, why did you decide to get into databases? Since you're out here inspiring others, you have to tell us what inspired you.
Yeah, so I think part of that is Mei Shin Shu at Harvard. You may not know Mei. She's still in the community. She's at Oracle. She's a big shot there, many years in research. At Harvard at the time, computer science was not a cool major to be in whatsoever. Everybody wanted to be in finance in Hollywood when I was going to college, and computers were for boring people, which was just fine for me. There were very few of us. But the cool classes to take when you got big were graphics and operating systems, for whatever reason, in that department. Those were the sort of hardcore classes. And if you took the operating systems class and you were super cool, Mei had a special graduate seminar in databases. And so she was very much an inspiration. And then, so the story is, I needed a job after college, and my sister was a PhD student at Berkeley, and she saw a sign up on the board for a Unix system administrator at IBM Almaden. And she said, hey, would you like this job? And I was like, I don't know. She said, well, it's a really good lab. These are really good people. And I thought, okay. So I talked to somebody. Memory serves it was Laura Haas. I'm not sure. And they said, would you like this job? I said, I don't know. This Margot Seltzer has a cool job for me in Boston. I don't really want to be a Unix system administrator that much. And she said, would you like to be a pre-doc? I thought, sure. And so I went to IBM and got to work with people like Hamid Pirahesh, and they trained me. So really, it was just that fortune that I had.
Hi, Joe. Congrats on the award. Can you say a few things about your experience as a CEO for 2 years, and how does an academic become a CEO?
Sure. And I know there's people in this, probably other people in this room who've done the same. So I don't know that I'm unique. Running a successful company is a lot about people management and process management. Having good technical ideas is a very small ingredient in building a successful company. And there's a big learning curve as a startup CEO, and so everybody goes through that. I would say the hardest thing, the hardest lesson I learned was when you get a group of people together, you start with 3 in our case, and then it grows a little bit and a little bit. At some point around 20, strange things start happening socially where things that you thought were given, decisions that are getting made, conversations that are happening, we're all ad hoc and friendly, and at some number of people stop trusting each other, and they need structure. So we would get questions all of a sudden one day like, what are you and Sean doing in the conference room? What are you talking about? I don't know, same stuff we always talk about, but people began to get concerned. So I would say the people management skills are the hardest thing to learn, and understanding why larger groups of people require structure and how to build that structure. Those of you at big companies who just walked into the structure, it just looks like an edifice that you inherited, but there are reasons why these things evolve. And then the other thing I'd mention, which I was told and did not believe, but it's very much true, is that the culture of the company follows from the leadership. So what comes later is a lot to do with the people who started it, and so I'm so grateful to have started Trifacta with really kind, good, smart people, and I think if you're going to start a company, optimize for that.
Hi, this is a great talk. As a young researcher, I'm curious, because you've worked in so many different and interesting areas, how do you go about thinking about what projects to take on and what fields you want to look at?
That's such a good question. So I think when I was younger, I would work on sort of whatever was in front of me that seemed fun, and I think I worked on a variety of different things. And I got to a point, I think I got tenure, and at some point I got the feeling that people thought I was rather clever, but they didn't really know what I did. It was like, oh, Joe, he's a smart guy. It's like, I don't want to be, that's not, you can't get famous for being just kind of a smart person, right? And so I saw some of my senior colleagues who had these projects that had many years of focus and throughput. And so I chose to do a little bit of both, very deliberately around, when I was 6 or 7 years in, to say, I'm going to have some long-term goals, and I'm going to follow them. I'm still following some of them 30 years later, while I'm doing some fun things on the side. And so I've tried to, in my group, have a few people that were working on kind of my through themes, and then if there were students who wanted to work on some other stuff, that was always fun too, and so I've tried to keep a portfolio of projects. And at my current stage, I'm really trying to focus, because I felt like there were too many projects, and really focus in on those longer term projects, which is a luxury of tenure and age. Yeah.
Thank you.
Were you there before me, or I don't know?
No, you were first. Go
Okay.
ahead.
Congrats, of course, Joe. I've known you for way too long, actually. What is your view of the industrial landscape vis-a-vis the academic and then the startups kind of thing? What I meant by industrial landscape is the bigger traditional kind of companies. I'm sure you are aware how IBM research has sort of, come down in terms of number of people, this, that. So do you have some concerns, this, that, about what's happening outside of academia, outside of startups?
Yeah. I think, there's good news, bad news. On the good news front, there's never been a more energetic time, I think, in industry for research in databases in terms of the number of companies that have very large projects that are talking about them in public and trying to get us to use them. Back in the days of IBM, it was mostly just IBM and Oracle, and then Microsoft sort of joined. But it was these very great, very small number of companies, and now we've got any cloud provider and many others. So it's exciting to see all the new entrants in the field, and I think cloud opened up so much opportunity. But you're right that I think the research lab, the industrial research lab as we've known it, is outside of some notable exceptions, Microsoft basically, not something we quite have the way we did back in the days of IBM and Bell Labs. And that's a shame. I mean, it is. That IBM research culture was a beautiful thing. I was so blessed to be there. You folks had set up such a great culture. And I encourage more of it, and I know we have Johannes Gerke in the audience here running Microsoft Research, so people from our community can make a huge difference in this space. And both grateful to them and inspired by them, and I hope we can see more. I hope we can see more. Yeah. Young lady on the left.
Hello. I'm wondering, academia to industry is a very common interest, a very broad interest, and I'm wondering if you can talk a little bit about the conceptualization of Trifacta and how you went from the theory of data wrangling to a product.
Thank you, Orly, for that question. I did not plant her, but she's a good public speaker. I have to give a lot of credit for Trifacta to Sean Candell, who is the lead graduate student on the project. He built the prototype, which is still live on the web. You can use Data Wrangler. And there's going to be a demo today of a project from Microsoft, and you'll see it has a strangely familiar interface if you go look at Data Wrangler. So Sean's work continues to inspire. Going from a research prototype that's a little bit of JavaScript on a web page to a product that's an enterprise product in particular that supports all the things that big companies require is a huge engineering effort and also a creative effort. One of the cool things at Trifacta that some of our community may not spend as much time on was the amount of user study research that we did. So we had designers going off and interviewing customers and doing user studies all the way through. And that's something that I learned quite a bit from in that experience. But hardening a product and shipping it and then pivoting from big data Hadoop to the cloud and building a serverless infrastructure, those were all things I couldn't even have imagined when we got started.
Thank you, Dr. Hellerstein.
Thank you, Ms. Hellerstein.
Hi, Joe. Thank you for being such an inspiring figure. I remember sitting at your WebDB keynote, and I turned to Juliana and I told her, wow, is there anyone like him? Anyone else in this community? So thank you again. So I just want to hear your thoughts about our DEI initiative, the Diversity, Equity, and Inclusion initiative, and if you think of something that we could be doing, something simple that we could be doing that would give us a push in this community.
Yeah, I want to be very humble in answering that question because I don't think my experience is super broad, but what I'll share is that I was the DEI officer on the Berkeley CS faculty recruiting a couple years ago, and it was a big learning curve. I learned a lot. But one of the things that I learned was that institutional buy-in on this stuff is absolutely critical. And if you go look to hire in a diverse and equitable way, you will find great people. And so it's just a thing you have to commit to, and it has to be supported up and down so that people who haven't been thinking about it can learn and then execute. It's really a thing of doing, not of believing. And so I'm so grateful to you folks for showing us that leadership, and I think the whole community needs to pay quite a bit of attention.
Thank you.
Yeah. Hi, Joe. Thank you for the talk. So my first ever SIGMOD was SIGMOD 2000 in Dallas, Texas. And I remember attending your talk about the EDIS work, and you were very energetic and like jumping over the slides. And I did learn a lot from this. That was SIGMOD 2000, my first year as a PhD student. 23 years down the road, you are not less energetic or less passionate than you were before. So what is the secret of keeping that energy and passion so we all can learn?
Maybe it's children. I'm not sure. Thank you for that. It's kind.
And with that, we're going to thank Joe once more. And we'll let you get about the rest of your day. Thank you all.